With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us solve this question. The question says the upper half of an inclined plane with inclination angle phi is perfectly smooth, while the lower half is rough. A body starting from rest at the top will again come to rest at the bottom if the coefficient of friction for the lower half is given by. Now, in this question we have given an inclined plane with inclination angle phi, and the upper half of this inclined plane is smooth and the lower half of this inclined plane is rough, and it is given that a block starts from rest on the top point and it reaches to rest on the bottom point. Now it is given that the inclined plane have inclination angle phi and the upper surface is smooth and the lower surface is rough. Now it is given that a block starts from rest and it reaches to rest. Now this is moving in the downward direction, so there is change in potential energy. So the total change in potential energy will be equal to mgh. Now let us consider this block reaches at this point and it is moving in the downward direction, so it will face some friction force in the opposite direction, whose magnitude will be equal to the mu times normal reaction. Now let us consider the weight force, which is mg, is acting in the downward direction. So this component, this angle is phi, so this angle will also be phi. So this component will be equal to mg cos phi. So the value of normal reaction will also be equal to mg cos phi. Now from this we can say that the value of friction force will be equal to mu times normal reaction, which is mg cos phi. So the value of friction force will be equal to mu mg cos phi. Now we know that the block starts from rest and it reaches to rest, so there is no change in kinetic energy, no kinetic energy change, only change in potential energy takes place. And we know that from this point a friction force is acting in the opposite direction to the displacement, so there will be a loss in kinetic energy from this block. So we know that loss in kinetic energy, which will be equal to the total change in potential energy, and this will be equal to the work done by friction force. So the work done by friction force will be equal to the force into displacement. Now here the friction force is mu mg cos phi, so we will put the values here. The friction force is mu mg cos phi and the displacement is, now the displacement with some friction is this length, and this length will be equal to, let us consider it to be L, and this height to be h. So this total hypotenuse length will be equal to h by sin theta sin phi, and this is the half of this hypotenuse, so L will be equal to h by 2 sin phi. So here we will write the potential energy is mg h, so mg will cancel out with mg, and the value of displacement is h by 2 sin phi. So this h will also cancel out with this h, so the value of mu will be equal to 2 sin phi divided by cos phi. This will be equal to 2 tan phi. So the option D will be the correct answer for this question.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.